All right, check this one out. This has a distributive property. There's a variable on this side, a variable on this side. This is about as tricky and as crazy as we're gonna go in this class. And so, you know, it could get crazier for sure. Definitely could get crazier. But what I'm gonna do is I'm going to draw a straight line down, and I'm gonna keep my sides separated. And then the very first thing, what I like to write down is these are my steps. I like to write down D, C, I. And all that represents is use the distributive property first, then you're going to combine like terms, then we do inverse operations or solve. This one could also just be, okay, now solve it. Figure it out, all right? And so right here, I'm going to distributive property first, which means multiply once, multiply twice. You always have to clear that number that's out in front first. So I like to rewrite it, 6t. I'm going to write smaller because I don't have a lot of room here. Hopefully I can fit it all in there. Okay, I've got a few. You can't do this problem without rewriting it. You just got to keep track of all your stuff and make sure you're rewriting it. And there's just no way around that. All right, so 2 times 3 is 6. So I write it down as 6t because there's a variable right there that needs to go with it. 2 times 5 is now 10. So I go right like that. All right, now I've got variables on both sides. I need to get the variables to go together on both sides. Okay, this is where this one gets kind of weird. All right, the weirdness here is that I can subtract 6t from this side, and when I go to do it on this side, something weird happens. Okay, this will now cross out here because 6 minus 6 is 0, but wait, 6 minus 6 is also 0, and we have a problem, right? Well, do we have a problem? I don't know. Let's rewrite this down. Negative 4 is greater than 10. Is negative 4 greater than 10? These both canceled out. They both go to 0. We know we have one of two options. We have no solution or infinitely many solutions. It's no solution if this is false. It's infinitely many solutions if this is a true statement. Now, is it a true statement? Negative 4 is greater than 10. No, this does not work, right? This is not true. This is a big false, right? No. Doesn't work. So what do we say about this? We say no solution. And you could abbreviate, or you could write it all the way out, solution, right, like this. Or you could just write this symbol. And everybody in the math community knows that symbol means no solution. All right? We know it's no solution because no matter what number you would plug in or substitute into the t location, no matter what you plug in there, it will never allow negative 4 to be greater than 10. No matter what, it's just never true. Negative 4 is not greater than 10. Okay, let's do this one down below, right over here. Okay, this one's sort of weird. All right, we're going to do the distributive property, and we're going to multiply once, and we're going to multiply twice. Okay, 2 times 2 is 4, so we're going to go 4x, right, like that. 2 times this is including the negative, so it's a positive times a negative is a negative. I write it down as a subtraction. 2 times 3 is 6, so I write it down right like that. And then I'm going to go less than or equal to, and I'm going to write down all this stuff. 9 plus 4x. All right. Now I need to get my variables on the same side. All right. So I got to undo stuff. I'm going to subtract 4x right here. In order to get them to move to the other side, I undo it on one side. And by sides, again, I like to draw my, straight down through like that. I draw a straight line. And I'm going to undo this minus 4x, both sides. But you see, this is when weird stuff happens. What happened to my variable? That's really weird. The variables are actually identical on both sides. So what ends up happening is this will cross out and this will cross out. Because 4x minus 4x turns into 0. And I get negative 6 right there. Drop it down. Is less than or equal to. I didn't multiply or divide by negative, so keep it the same. Keep it facing the same way. And then 9 is right here. All right? Wait a second. No variables. That's okay. You know if the variables cancel out, you have two options. No solution or infinitely many solutions. All right, so in this case, is negative 6 less than or equal to 9? Yes, it's smaller. It's less than. Think of a number line. Here's my number line. Here's negative 6, and 0 is somewhere right there. Then 9's way over here somewhere. All right, and so we think, yes, it's definitely less than. This is true. And if it's true, then we say, yes, this will work. This is a big yes. It will work. Now, for what values? So what will my x value equal? Well, they'll always cross out, and no matter what I put in for the x value, they will always be -6 is less than 9. And so no matter what value I put in there, the variables will always cancel. And if that's the case, then we say that it's infinitely many solutions. And we would write it like this: infinite solutions. And you could abbreviate like that, solutions, or you write it all the way out. Or here's my symbol. Use this symbol, and everybody knows that the answer, if you write down that little infinity sign like that, that is infinitely many solutions as a potential answer for this one, if they cancel out. And if it makes it a true statement, -6 is absolutely less than 9, then yes, it will work for every number that you put in for x. Whether you put in like 2 or 5 or 500, they'll always cancel out like that. All right, so with that said, here is no solution, infinitely many solutions if our variables will cancel out.